Algebra 2, Unit 10, Lesson 5. And in this lesson, we're going to learn how to solve logarithmic equations. You're going to have two different types of logarithmic equations. One of the types is where all of the logs are on one side of the equation or one side of the equal mark. The other type is where you have logs on both sides of the equal mark. When you have all of the logs on one side, you're going to eventually convert to exponential form to solve those. You may have to condense the logs using your properties and then move them to exponential form and solve. When you have logs on both sides, in order for them to work, your log and your base have to be the same. So you would have to have a log base 8 on this side with a log base 8 on this side. If this was log base 2 and this was log base 10, you couldn't do it. The base logs have to be the same. So if your logs are on both sides of the equation, then the log base 8 will cancel on both sides and we'll just be left with a 3x plus 7 equals 7x plus 4. So these are fairly simple to do. Sometimes these will require factoring. Sometimes you'll have more than one answer. Sometimes you'll have to throw answers out. When what you get causes what's inside of this part, and I tend to call this the x part. If what you get when you plug the number into this ends up being negative, then you have to throw that answer out because what ends up being here can never be negative. And if you try to put a log with a negative number in your calculator, it's going to give you an error message. It just doesn't work. You can't have logs of things that are negative. It just doesn't work. So let's get into some examples. With this one, all the logs are on the left-hand side, so I know that tells me that I need to convert that to exponential form. To convert to exponential form, remember the base of the log is the same as the base of the exponent. So my base here will be 7. Remember, logs are equal to exponents, so my exponent here would be a -2, and then that equals the rest of it, n. And your directions for all of these are going to be solved for the variable, whatever the variable is. Well, 7 to the -2 is 1 over 7 squared, and so that leaves me with 1 over 49. So n is 1 over 49. For the next one, since my log base 8 and my log base 8, since that is the same, I can drop the log base 8, and this is the same thing as 3x plus 7 equals 7x plus 4, and then I could just solve that simple equation. If I get the 3 on the other side, I'm going to have a 4x. If I move the 4 to the other side, I'll have a 3, and so 3/4 is equal to x. And then when you are solving this type of logarithmic equation, you do need to get in the habit of checking your answers to make sure they're not going to cause this or this to be negative. If they do, they have to be thrown out. So if I plug 3/4 in, 3 times 3/4 is 9/4, and 9/4 plus 7 would give me a positive number, so I don't need to get rid of that. If I plug 3/4 in here, 7 times 3/4 is 28/4, plus 4 would be a positive number, so I can keep the 3/4 as my answer. Looking at this one, all my logs are on the left-hand side, so I know that needs to be put in exponential form. So that would be 2, my base is 2, my exponent is x, equals 8. That's very similar to the problems we did in lesson 1. 2 to the x is equal to 8 as a power of 2 would be 2 cubed, so that means x equals 3. So they're still going to mix in some of the old problems that we already know how to do with these logarithmic problems. With this one, the first thing I need to look for is, does this have all the logs on one side or are they on opposite sides? This one, all of the logs show up on the left. So in order to solve this problem, I need to use my properties of logs to condense this because I can't convert it to an exponential function until I have only one log on the left-hand side. Now, since these log bases are the same, I'm allowed to combine these using multiplication. Remember, when logs are exponents and we have a plus with exponents, that means those were actually multiplied together. So we've got log base 2 of x plus 1 times x minus 5 equals 4. I can multiply those together. So I've got log base 2 of x squared minus 4x minus 5. I got that by using FOIL, and that equals 4. Now all my logs are on the left, and it's the simplest log that I can possibly have. So now at this point, I'm going to convert it to exponential form. So 2 to the 4th is equal to x squared minus 4x minus 5. I would get 2 to the 4, that is 16. I'm going to move the 16 to the other side. So 0 equals x squared minus 4x minus 21. Negative 5 minus 16 is negative 21. Are there factors of 21 that subtract to give you 4? And that would be yes, 3 and 7. So we have an x and a 3, an x and a 7. This tells me the signs are different. The minus goes with the big number. So it's a minus 7 plus 3. And we end up with two answers. We have x equals negative 3 and x equals 7. The next thing I need to do is check. Make sure neither one of these is going to make either of these a negative. If it makes that x part negative, you have to throw it out. So negative 3 plus 1 is a negative 2. I have to throw that out because you can't have a negative number here. So the negative 3 will not work. If you plug in 7, 7 plus 1 is 8. 7 minus 5 is 2. Those both end up being positive, so we can keep the x equals 7. Now, this negative 3, if we had plugged it in here, it would also be negative. If one of them is negative and the other ends up being positive, you still have to throw it out because if either of them are negative, it will not work. In this one, notice we have logs on both sides, but here we have a problem because we have too many logs. We have to condense it so that we only have one log on the left and one log on the right so that the logs will drop out. So I'm going to have to use my properties to combine these two things together. If I do that, I'm going to have log base 7 of 36 over x using those properties from the last lesson. That equals log base 7 of 4. Now that they both have a log base 7, I can cancel that out. And I've got 36 over x equals 4. So 36 equals 4x. So 9 is equal to x. If I plug that back in and check it, that's already positive. Plug 9 in there, it's going to be a positive there. So I can keep the 9. I don't need to throw anything out. And it is possible sometimes to have no solution. Sometimes no matter what you plug in, it's going to give you a negative. And if that happens, no solution would be just fine. For this one, that's a tricky problem because it's got two logs in it. But do we have a property that is going to enable us to get rid of a log within a log? We do not. So the only thing I'm going to be able to do here is I have to treat this like it's my x value. In other words, I'm going to change this to exponential form, and I'm going to end up doing it twice. So watch what I do here. I'm going to treat this as one kind of separate problem. That's my x part. And remember, if I've got log base 5 of an x part equals 0, I can convert that to exponential form by taking the 5, that's my base, to the power of that number, 0, because logs equal exponents, so that's my exponent. And then that equals my x part, log base 3 of x. If I simplify that, 5 to the 0 is 1. And I've got log base 3 of x. Now, it's another simple log. I've got the log on one side. Now I can convert it to exponential form again. So, the base is 3 to the power of 1 equals the x part. 3 to the 1 is 3. I could plug that back in and make sure it's not going to force any of my logs to be negative. It doesn't, so I'm allowed to keep the 3. This one, some students would have trouble with. They'll look at this and say, okay, this has got logs on both sides, and so then they'll try to drop the log base 6 and set those equal to each other. Well, you can't do that here because this plus 1 is separate from the log base 6. It is not part of this. It's a separate term. So we can't combine that together to make it log base 6, and I cannot say 2x minus 5 plus 1 equals 7x plus 10 because this 1 has no log base 6. So I'm going to have to find another way to do this problem. The easiest thing to do is going to be to get the logs on the same side and get anything that does not have a log on the opposite side. So what I'm going to do is I'm going to move this log 6, 7x plus 10 to the left-hand side and move the 1 to the right-hand side. So when I do that, I have log base 6 of 2x minus 5 minus log base 6 of 7x plus 10 equals negative 1. Then I can condense these into a single log. That would be log base 6 of 2x minus 5 over 7x plus 10. I use my properties. That gives me a negative 1. Now I can convert this to exponential form because all my logs are on one side. So 6 to the negative 1 is equal to the rest of it. 2x minus 5 over 7x plus 10. To solve that equation, 6 to the negative 1 is 1/6. That equals 2x minus 5 over 7x plus 10. And then to solve that equation, I can cross multiply. 1 times 7x plus 10 is 7x plus 10. 6 times 2x minus 5 is 12x minus 30. And then I could solve that simple equation. I'm going to move it up here to solve it. So 7x, I'm going to subtract 7x from 12x. That will give me a 5x. I'm going to add a 30 to the 10, and that would give me a 40. And then 40 divided by 5 is 8. So x equals 8. Then I'm going to take the 8, remember, and plug in to make sure none of these are negative. 2 times 8 is 16 minus 5 would give me a positive. 7 times 8 is 56 plus 10 would give me a positive. So the 8 doesn't give me anything negative, so it's okay to keep that as my answer. For this one, the first thing I notice is that I've got logs on both sides, but I've got more than one log on this side, so I know I need to use my properties to condense that a little bit. So log base 7 of x plus 2 log base 7 of x. The 2 log base 7 of x would be log base 7 of x squared. Remember, using your powers property. So I'm just going to do that first. Log base 7 of x plus log base 7 of x squared minus log base 7 of 3 equals log base 7 of 72. Now I can put these together. These two would be log base 7 of x times x squared is x cubed, minus log base 7 of 3 means that goes over 3, and then this would be log base 7 of 72. And now that I have my log base 7 on each side, I can get rid of that. So x cubed over 3 equals 72. If I multiply by 3, x cubed equals 216, and then I would take the cube root of both sides, leaving me with x equals 6. The next thing I do is plug the 6 in to make sure it doesn't make anything negative. So if I plug 6 here, that's positive 6, a positive 6, and then those are already positive, so we don't have to throw anything out. For this one, I only have logs on the left-hand side, so I'm going to put those together. If I do that, this would be 3 squared, which is 9. So I'm going to have log base 4 of 2x over 9, because that 3 squared would give me a 9, and that was a minus, so it would be a 2x over 9, and that equals 2. Now my logs are all condensed on one side, so I know I need to convert it to exponential form. So 4 squared equals 2x over 9. 4 squared is 16. 9 times 16 is 144. If I divide by 2, I have x equals 72. If I plug back in, that will not make it negative, so we can keep the 72. Here I have log base 5 of 4x minus 2 log base 5 of 2. That would be a 2 squared. I moved the 2 there. So I have log base 5 of 4x over 4 equals 0. 4x over 4 is just x, so that's log base 5 of x equals 0. 5 to the 0, I convert it to exponential form, equals x, so x is 1. That does not make the x part negative, so I can keep it. So here are two more examples. I want you to pause the video, see if you can solve these on your own, and then I'll give you the solutions in just a few minutes. Here are a couple more examples. Go ahead and pause the video, see if you can work through these on your own, and then I'll give you the solutions in just a few minutes. For the first one, I'm going to convert that to exponential form. So I have 2 squared equals the x part, x squared plus 7x plus 16. 2 squared is 4. I move the 4 to the other side, making that a 12. I'm going to factor. Factors of 12 that add to give me 7 are 3 and 4. So I have x plus 3 and x plus 4, giving me x equals -3 and x equals -4. I do need to then plug those numbers in and make sure they are positive. They both end up giving me a +4 inside, so I can keep both of the answers. For the second one, I need to condense these logs. I need to get that log over on the left-hand side with the other one, so I can use my properties to condense it, and I need to move the 2 on the other side. So I do that right here. Then I use my properties to condense these logs. So I have log base 3 of x squared minus 1 over 3x plus 3 equals 2. Then I convert it to exponential form. So I've got 3 squared equals x squared minus 1 over 3x plus 3. So 9 equals x squared minus 1 over 3x plus 3. Multiply this to the other side, getting 2x plus 27 equals x squared minus 1. I move everything to the other side, giving me something that is factorable. Factors of 28 that subtract give me 27 are 28 and 1. And if I set those equal to 0, I get 2 answers, 28 and -1. Now, if I plug 28 in, it gives me a positive here, it gives me a positive here, so that's fine to keep 28. -1, this -1 is a special case. We haven't talked about this yet, and this is something I failed to mention earlier in the video. I told you that the number here has to be, or it cannot be negative. I told you that, but I didn't say anything about what could it be 0. Okay, so let's look at this. If I plug -1 in, -1 squared is 1, 1 minus 1 is 0. 3 times -1 is -3, plus 3 is 0. They both end up being 0, and we didn't say anything about 0 earlier. If you plug 0 into the log function and put log 0, it will give you something undefined. You can't do 0 either. So what I really probably should have said is the number inside here has to be positive. It can't be 0, it can't be negative. And let me show you why. This is a great example to show you why that is. If you look back to this section right here, if we take 9 equals x squared minus 1 over 3x plus 3. If I factor that to see what happens, I've got 9 equals x plus 1 times x minus 1, because that's the difference of squares. I take out a 3 and I've got x plus 1. Look at the x plus 1. It cancels out. So when that cancels out, that tells me that whatever would go here is going to be gone. We throw it out. So the -1 here has to be thrown out because it makes our x part of the log equation 0. And we can't have a 0 in our x part for a log. So if I cancel that out, and notice what I end up with, 9 equals x minus 1 over 3, 27 equals x minus 1, and if I move the 1 over, I get 28 equals x, which is our answer that works. The other one gives us 0, doesn't work, we have to throw it out. If I had seen this up here, or even right here, I could have canceled that out before I even set up my exponential form and not even had to worry about the -1. It would have knocked itself out before even having to test it. But we need to understand that if I plug that in, it gives me 0, it's gone, it's no longer an answer.